Welcome to solverfy.
A surprising thing happens if you race different objects with different mass distributions down an incline. If it's a fair race and they all start from the same height with an initial velocity of zero, they may not necessarily all reach the bottom at the same time. And in order to understand this, we can use conservation of energy with the idea that the potential energy of the object up at the top is going to convert into kinetic energy down at the bottom. So U initial plus K initial, which is zero, is equal to U final, which is zero, plus K final. And the trick here is that if the object rolls, then the kinetic energy is actually a sum of two different kinetic energies, what's sometimes called kinetic energy of translation, plus a term for kinetic energy of rotation. And we'll start looking at those. So the translational kinetic energy is just 1/2 the mass of the object times its velocity squared. Rotational kinetic energy depends on a property called the moment of inertia I times the angular frequency squared. I is moment of inertia, and that will depend on the mass distribution. Omega is the angular velocity. Okay, so let's do some details because there are some simplifications when we work out this conservation of energy. And as an example, we are going to look at three objects and find their moments of inertia in a table. So yeah, you can calculate these if you know how the formula works, but otherwise you can look them up in a table. A is a solid disk, and it has a moment of inertia of 1/2 its mass times its radius squared. The B object is a solid ball, and its moment of inertia is 2/5 mr squared. And finally, a hoop is kind of like a ring, if you will. Hoop or ring. It's hollow. It kind of looks like it's got a wall and a donut. Okay. Its moment of inertia is mr squared. Now pay attention to the factor in front of each one of these. They all look like something mr squared, but each one of them has a different factor in front. And that means that the potential energy they start with is going to transfer into kinetic energy in a different way. So let's just write out the relationship as the moment of inertia for an object is some form factor that I'll call alpha times mr squared. Okay, we see the alpha sitting in front of the mr squared for those. The other thing to realize is that rolling without slipping puts a constraint on the omega. It's not too complicated to understand that the velocity, the linear velocity of the rolling object is r times omega. And so if we set up this equation, U initial, so this is our conservation of energy equation. U initial is equal to 1/2 mv squared, v final squared, plus 1/2. We're going to put in the moment of inertia as alpha mr squared, and we are going to substitute in for omega squared. Whoops. That whole quantity is squared. And we see that we have 1/2 m v final squared times 1 plus alpha. And on the other side, we have mgh. So they're starting from some height above ground, all the same, and dropping the same incline with very little friction. So if we go through this, what we can do is notice that the mass does not matter. The radius didn't even matter, but we can solve for v final. And it's a little bit less than what you would have if the object just dropped straight down from height h, or went down, slid down the incline with no friction. But notice what this says is that the smallest velocity goes with the largest alpha, or the smallest alpha goes with the largest VF. So we can now go, and based on those factors in front, there's a one that looks like it's missing there. So the hoop, it has the largest, and it is going to come in last. The solid ball has the smallest, and so it is going to win the race. And finally, the solid disk is somewhere in the middle, so that will be middle. So the ranking would go BAC or CAB, depending who you want to start with, the guy who lost the race or the guy who won the race. But the solid ball, because it has the smallest moment of inertia factor out in front, should be the winner. And if you have a short incline, you may not be able to tell the winner very easily, but certainly with a long enough incline, it will become clearer, the difference in the speeds as these objects roll down.